Hey, a big welcome out there to all of our manufacturing fans, and welcome to another version of SolidWorks Manufacturing Live. I'm your host today. My name is John Milbury. It's a pleasure to be here, but an even greater pleasure is to have a very special guest that I've known in the manufacturing world for well over 20 years now, and that's George Panagiotakakos. And George is the founding owner and director of GPI Machine Tools. And George, welcome today.
Thanks, John. Good to be here.
Well, we're glad to have you. And I think that, I think back of all of the conversations that we've had over the years. And we decided that, all of the insight and all the special abilities that you have in the manufacturing world, that this would make a great session today to kind of feature your knowledge and discuss it a little bit with our audience, because it's just, what you do is really incredible. So, George, I want to start out with, where are you located at? Your, GPI Machine Tools where's it at?
GPI Machine Tools is in North Texas. We're in the DFW area. We primarily service North Texas and all of Texas, but the entire Southwest as well.
Oh, fantastic. And, George, we're both in the Dallas-Fort Worth area, right? We live about 20 minutes apart.
Right.
So we've done a lot of things together over the years, but, GPI Machine Tools has been in business now for what, over 20 years, right?
Yeah, 2003 is when I started it. Yeah.
Okay. Yeah. You guys offer quite a number of different things. And one of the, we're going to go over each and every one of these really cool things that you do. I think everywhere from machine tools, right, to software, to probing, things like that, as well as NC programming software, and even post-processors. So you're kind of the full gamut, right? You do kind of everything.
Yeah, we try and capture our customer, John. We try and offer our customer everything that we think is valuable to them. So, we think of ourselves as a value-added addition to any of our customer base, or even just the area in general.
Well, that's fantastic. So, here in North Texas, where you're based, I would imagine you get a lot of aerospace and a lot of oil and gas companies. Is that correct?
Yeah. So our area is really focused around aerostructures. When you say aerospace, most of the aerospace manufacturing that's done around here is focused around aerostructures. Not necessarily, like engine parts or fuel parts or things along those lines, but mostly airframes, panels, structures, things along of those lines. And on the energy sector, that would be more like fluid ends, mud pumps, and everything that's connected to that, from subsea to anything online or sour service. All of that is done here in North Texas and also down in the Houston area.
Yeah. So speaking of that, Houston's kind of the epicenter, right, for oil and gas here in the United States. You talked a little bit about sour service. Can you explain what sour service means when we're talking about oil?
Sure. Yeah. So there are two types of petroleum. So we think of it as sweet crude, which is like what comes out of the Permian Basin, which is very easy to find and very easy to extract out of the ground. And then sour service is going to be that heavier crude, that more difficult to find, more difficult to extract petroleum out of the ground, which means the materials that are used either in, like the packers or any of the piping or any of the safety valves that go into that are a completely different type of material as opposed to non-sour service.
Got you. So I think then probably I could say there's a lot of sulfuric acid and a lot of volatile compounds, right, in the sour service, so to speak. And you're probably going to need what? Some materials with high nickel, right, that are acid resistant.
Yeah, so Inconels, Monels, Hastelloys, yeah.
The fun stuff to
The
machine.
fun stuff, yeah. The fun stuff, hey, John, even like 15 or 20 years ago when no one even knew how to machine that type of stuff.
Yeah, gosh. I know that I've had my fun with it in the past, and it's good to see that things haven't changed that much as far as what they're using for sour service. So let's talk a little bit about, a little bit about the machine tools that you represent. I noticed that I believe the name of the machine tools that you sell are basically called PAMA. Is that correct?
Palma, yeah. So we
PAMA.
offer the Palma group, and we also offer Promac. Both machines are designed and manufactured in Italy, and they're almost like a specific to a project type machine. So if a customer's got a project that they're trying to obtain either a certain amount of parts per month or per week, or they're trying to obtain a level of accuracy, that's where these machine tools really shine.
So it would be that these are probably specialty machine tools, highly accurate, very rigid, very large, so to
They
speak.
are, John, yeah.
Okay. I was looking on your website at a picture of one of the gantry mills, a gantry type with a vertical CNC machining center. Yeah, it's huge. And of course, gantry mills by their very nature are huge, right? But this one is especially large. And it looks like that they're pretty big, accurate, powerful, and expensive machines.
They are. And there's certainly a long lead time. This is not something that a customer just wakes up one morning and decides, well, we want a machine like that. Goes through an entire developmental process of, are we sort of looking at the right machine tool? Are we not? Is it the right part? How do we upload? How do we get it onto the machine tool? How did we get it off the machine tool? Do we do inspection on the machine tool itself? And on the Palma side of things, the head of the machine itself is interchangeable. So we can go from a vertical spindle to a horizontal spindle and to everything in between, and actually remove the whole entire head and put another head in its place.
That is really something. And I noticed that I'm looking here, and I've noticed that this one vertical mill that you've got. This one gantry mill goes up. What is it? 1,323,000 pounds.
Yeah. So yeah, it's literally the bed of the machine is sitting on a foundation underneath it, and customer will literally just drive right onto the bed of the machine with either a forklift or overhead cranes. So the bed of the machine is floor level.
Oh my gosh. So that's how it supports that sort of weight. So
yeah, and it makes it easier to try and get the part on and off of the machine tool, as opposed to having something floating in the air, even if it's just, a meter, half a meter, or 2 meters off of. It's much more. It's safer and quicker to be able to just have everything on one level.
So these machine tools are obviously very expensive, and you're probably doing, a lot of advanced integration with things like probes and other things. I noticed that, and we've talked in the past about this, that you offer, a lot of Renishaw probing services, and I think customization at the controller level using Macro B and a few other things. Can you go in and kind of give me an idea on what you would do with a large machine like this, as far as, the Renishaw probes, and what's involved there?
Sure. So if you think about a large part, any large part really whatsoever, it's how do you find the features or the datums that you need to locate. In this rib in particular, how do you find, because this rib starts out as a gigantic block of aluminum 7050 or 7075, 7025. How do you find it in order to start creating datums and then do your machining? And we use probes to do that. We will use either a radio probe if the distance from the spindle to the connection back on the machine where it talks back to the controller. We'll use radio probes. If it's able to travel along the column, then we'll use an optical probe. And insofar as the programming side is concerned, we can use that probe to not just locate a work offset or a work coordinate, but we can actually use that probe to locate a part number. So one of the things that we would do is the forging itself coming into the machine or the part itself coming into the machine may have a specific feature on it. And we'll come in with the probe and probe that one feature that's already on either the forging or the part as it's coming into the machine tool.
Mm-hmm.
And we'll do an and if statement in macro B saying, if it is this diameter feature or this diameter hole or this diameter something, then call up that program number. And that allows the machine to not only identify the part, but now it has the correct program, the correct tooling, and everything in order to run that part. Whereas, maybe an operator might have called up the wrong program and doesn't realize it until the first part is, or the first tool is run. Let's hope he doesn't run the first part, but until the first tool is run, and now you've got a scrapped forging or a scrap part. And when you get into parts of this size, this caliber, it's a very, very, very expensive piece of material that's just going to be sitting somewhere as a scrap piece.
I can only imagine. So macro B is the programming language that you use within the controller itself, correct?
Yeah, so macro B is what FANUC has been using and continues to use even to this day as their sort of background generalized macro. When I say macro, I mean large way of calling out different variables and making those variables work within the control to find and do certain things. Tell the control, if you think of a can cycle, a drilling can cycle or a tapping can cycle or a threading can cycle, all of that is written in macro B.
Right. Okay. That is awesome information. Now, also too, do you do anything special to take some of these tombstones or other things, these multiple tombstones that can get loaded on the machine? Do you have any sort of tricks on how to identify those different types of B-axis, tombstones, or what do you do with those?
So years ago, customer came to me who had a pallet pool system, a horizontal machining center pallet pool system, and wanted to run lights out. And they wanted to run different pallets, different parts during the night when no one was there. And they asked me, how can we do that? And my answer to that was on the tombstone itself is to, up in the upper right-hand corner, to machine just a small bore. The bore could be from 1/2 inch, it can be anything, 1/2 inch, 1 inch, 1 1/4 inch, 1 1/2 inch. And each tombstone had a different size diameter bore in that upper right-hand corner. So when the shuttle happened, the old tombstone came out, the new tombstone came in. The first thing that I did was call the probe up to go and probe that hole. And if the probe found, let's just say, a 1 inch hole diameter, that variable was written. And then I wrote a macro B statement that said, if it's that variable or if it's that number, then call this program number and this tooling list. And the tombstone was able to run successfully with the correct program and the correct tooling. When it was done and it shuttled out and the next one shuttled in, Again, the probe came in, found that hole. If it was a different diameter hole, let's just say in this case, 1.5-inch diameter hole, or a 50 millimeter or 75 millimeter, the if then statement took over again and said, if it is that, then run this program number. And it allowed that program to run, it allowed that customer to run their programs and their tombstones lights out. Now, we did have other things on the machine tool, John. We had tool break detection lasers, and other ways that permitted the customer to run lights out. It wasn't just a matter of, just call the program up and off you go. We needed to make sure that the tools were actually there and not broken. We needed to make sure that there were redundant tools in the tool carousel so that if there was a broken tool, then you could find another tool of that same size.
Okay, let me make sure that that I understand it up to this point. When we talk about lights out, we're talking about, well, basically everybody goes home from the night, but the machine tool stays active, right? It's running parts all night long. And it sounds like to me that macro B inside the controller itself and your ability to program that has a lot to do with how that particular cell is able to function all night long. And
it's imperative to it, yeah.
Yeah. So you talked a little bit about, being able to test and sense for things like breakage, tool breakage. How do you do that? If a tool does break, how do you know that it broke, George?
So on the Renishaw side of things, we have an NC4 laser, and that laser creates a beam. And for simple tool break detection, all we want to do is just make sure that that cutter comes along and breaks that beam. If it breaks the beam, we know that the cutter is there. If the tool comes along and it does not break that beam, then it throws an alarm and says, hold on a second, what's wrong here? It comes back and tries to find that tool. If it cannot find that tool, it means that the tool is broken. If it's a tool that can then be like, let's just say an end mill or a face mill or something along those lines, a redundant tool can be called out of the tool carousel. It runs through that beam as well. The beam breaks. The tool is active. It's good. They continue running. But if it's something like, let's just say a tap drill or a tap, now you've got a tap drill or a tap inside your part, and you don't want to run subsequent tools on that part. So you shuttle that part out and you bring a new tombstone in with a whole new set of parts, a whole new set of tooling, and that allows the machine to keep running through the night, even though that one tombstone has been sort of set off to the side.
I see. That is really interesting. That gets into just a lot of automation and a lot of what if and all the different scenarios that could possibly go wrong. And
we've done it too on turning machines, John. This is not just for like a machining center.
Mm-hmm.
We have, we'll install a touch probe just above the chuck or the spindle on a turning machine, and we'll just have tools just come and touch that before they run. If it touches it and it reads, it not only updates the tool offset, but it tells the program continue running. If it touches it and it finds out, hold on a second, I'm outside of an acceptable range, the next tool that comes up will be the cutoff tool. It'll cut that bar off. You start a whole new cycle again, and you have a redundant tool in the turret now that can continue running.
That is that is excellent, and that sounds like it's highly competitive with techniques that are being used all over the world. Tell me something. How do you account for tool wear? Like the tool's only got a certain amount of life in it. Do you track how long it's been active in the cut and how long that tool, do you change to another one? Because its life's kind of used up during the night. Does that happen? Or you just make sure you load everything up and make sure, well, we know that this will last all shift long. How do you do that?
So your optimal choice is to load up enough tools to run all night long. But you also know that tool life is an issue, right?
Mm-hmm.
And once you get to the 50th part, even though that tool looks fine visually, when you look at it, you say, oh, all this end mill looks okay, or this tap looks okay. We know that the chances for breakage actually kind of spike up after the 50th part. So we'll just put a redundant tool, another tap, a new tap, inside of the carousel or inside of the turret. And we say, we start a counter. Once we drop down to that 50th part, whether that tap looks good or doesn't look good, it doesn't matter. You go to that next tap. So you run 50 more parts.
I see. That makes a lot of sense. So give me an example. How successful are you typically in getting everything to run just fine overnight, lights out? Is it?
It's 100%, John. There is no option for me for failure. When a customer is calling GPI in, they've already gone through 5, 6, 9 other options. Either it's other customer, other suppliers, other engineers, or anyone else.
Okay.
And they come to us and say, okay, we were told that you are the guys that we need to speak to. And we don't let the customer down. We make sure that we do reach the goal that the customer is looking for.
That's fantastic. So, speaking of your customers, how do you find your customers, or how do your customers find you?
So there's a step-by-step process, if you can think of it like that. Most of our customers these days, John, come to us as referrals. So it's a customer that has spoken to another customer, or has been to a tool show, or has spoken to a machine tool company and has said, we're just not getting it. We're not there. For some reason, we are just not able to get to where we need to be. And the reference then comes, or the referral then comes to them and says, you need to contact GPI. They're the guys that get you where you need to be. On the other side of things, we have customer base. We have our customer base, our internal customer base that we've been supporting for the past 20 years. They come back to us all the time because they know that they can count on us.
I see.
But we partner with not just like Renishaw specifically, or Palma and Promax specifically, but even a competitor's brand.
Okay.
Their applications engineers or their sales guys or something do not want their customer to fail on their machine.
I see.
Right? Like, I'll give you an example. Let's just say you're a machine tool salesman. You sold a machine tool to one of your customers, and it's just not working. Something's not happening. It's just not successful. Now you've got an angry customer on your hand. You know that you can hope and rely that the customer will get to where they need to be, or that your team, your internal team, will get them to where they need to be. But there's a possibility that your internal team is in Kentucky, or that your internal team is on the West Coast, or something along those lines. And that customer needs someone on site. That customer needs someone local to help them. And that's when you would tell your customer, even though you're a competitor of mine, you will tell your customer, look, just contact George at GPI and they'll figure things out for you. Now, your customer is happy because the machine that he's purchased from you is doing what you promised him it will do. But he's also happy that we've come in and we've sort of taken that load off of them and helped them get to where they need to be.
Well, that sounds like that's true value add. Regardless of whether it's your competitors or not, in the end, it's really all about the customer, right?
Yeah, you would hope that's the goal here, that we're sort of all in this together.
So, all the years that I've known you to be one of the probably the best contract programmer that I've known, especially in the aerospace industry. And Can you tell us a little bit, what is a contract programmer, and why do they call you a contract programmer? Why would they call you to do something that they basically have the ability to do in-house?
Yeah, so we'll sort of start from the basics here of what is a contract programmer. Contract programmer is a programmer that does not work directly for the end user. So I'm not an employee for, let's just say, ABC Machine Shop. Why do they contact a contract programmer? They contact us because their team is just not getting it. For whatever reason, their team does not have either the time or the abilities to get a program up and running and do it quickly and successfully. Unfortunately, there are instances where their team has failed 4, 5, 6 times. And now they've got 6 forgings sitting on the floor and an angry customer. And they're just like, okay, we're not going to get this. We need to bring someone else in. And what I do is I put a contract in place with that customer that specifically says, I will work, or GPI will focus on this part number, and we'll hit this date insofar as programmings are concerned, insofar as the first run, first article, FAI, the whole 9 yards.
Oh gosh, well that sounds really interesting. I know that George, that we've collaborated a couple of times on some of your contract programming, and one of the things that I couldn't help but notice was that a lot of times they'll bring you in simply because they cannot create the solid model from these old antiquated drawings, and we found that out to be true in the aerospace company, or in the aerospace business, right?
Yeah, the life of a particular product, especially in aerospace, is sometimes 30, 40, 50 years. So you and I have worked quite closely on F-16. Everyone's familiar with the F-16 Falcon. What people aren't familiar with is that the original drawings were from 1964 or 1966. We're talking about guys standing on a blue board drawing things out by hand. And sometimes when either a machine part needs to be machined, even though it's the newer version of the F-16, that part still needs to be put on that new machine, on that new F-16.
Mm-hmm.
There is no solid model. Grumman doesn't have anything. Lockheed certainly doesn't want to create solid models for any of that stuff. So I will receive, what at one time was a 1 meter by 4 meter long blueprint, and I'll receive it just in little 8 by 11 snippets all the way across.
Oh my gosh.
Yeah. And somehow or another, with your help, we've got to create a solid model that we can then verify, because CMM needs a solid model as well, right?
Right.
The inspection guys, they need to be able to put this part on a CMM and check it on a CMM.
Exactly. So I tell you what, you've done some incredible programming on some of these machines, and I've been very impressed with what you've done out there in the industry. Are you doing anything at all with scanning? Does that come into account with anything that you do, or is scanning kind of something else that people get into with rapid prototyping and other things? What do you do much with scanners?
Yeah, so scanners are not quite at the level where manufacturing needs them to be. They're great, like you said, for prototyping, and they're great for sort of like quick type stuff or repair type stuff. But insofar as the general making parts over and over and over again, scanners just don't come into play, at least not at this point.
For the actual parts, but I have noticed a trend where companies are having their entire factory scanned, right? So that they can then simulate their factory. And that, of course, is something completely different than just scanning of a part per se. So,
Yeah, so if you think about scanning a factory, right, your tolerances are wide open. You can be plus or
right,
minus, like, I don't know, a few millimeters up to half a meter, but when you're scanning an actual part, you're down sometimes to the micron level, John. You're down to plus or minus 1,000th or plus or minus a couple of microns or something along those lines. And scanners just can't do it.
no, I totally understand. So, tell me a little bit about the CAM software that you use. I know that you've used many different CAM software in the past. I know that at one time you were a spree dealer, um, and what are you doing now? What CAM software are you using? And tell me a little bit about the post processing solution that's involved with that.
Sure. So the main focus right now is NCG Cam. They're based out of the UK, and they are the premier 5-axis machining software CAM company. The reason being, John, is because they're still a company that cares directly about their customer. They have an intimate relationship with their customer base. So that appeals to us because we have an intimate relationship with our customer base as well. So NCG Cam is capable of meeting the requirements that our customers need, but also meeting the requirements that we need as well in our company. We have access, John. We've got access to CATIA. We have access to all of the other CAM systems. It's not like we don't have access either to Vericut or anything along those lines. We do. We have access to it. But our preference is to work, like when I ring NCG Cam, I'm speaking to one of the owners, or I'm speaking to the guy that actually developed the software. When I'm working through a post, or I'm creating a post, or I will be creating a post, I'm speaking to the person that is in charge of their post-processing development. And that collaboration, that one-on-one contact makes things a lot more successful. It allows us to be more successful, which allows our customers to be more successful, but it also allows NCG Cam to be more successful because then they can take that post and offer it to other customers worldwide, right? They don't necessarily have to just specifically focus on our customer. We're focusing on possibly a machine tool or a controller that has a much broader implication when it comes to the post processor.
I see. Well, I can assume that NCG Cam then pretty much provides all the capability that you need to drive the machine tools that you sell, right? Among machine tools.
Yeah, they do. The posts are developed as we go along, just because controllers are being updated all the time, machine tools are being updated all the time, so posts need to be updated all the time. But the actual tool path, creating the tool path, creating the features to drive the tool path, that is something that NCG Cam has had success with for dozens and dozens of years.
Fantastic. So I can imagine also too that it's going to support what I would think would be a Swiss machine, multiple spindles and gang tooling and all that sort of thing.
Yeah, the focus for NCG Cam really is like mold making and 5-axis milling and 5-axis machining and simultaneously 5-axis milling. And that's really where our customer base has been leaning towards as we've sort of grown into a different niche in our manufacturing sector.
Very good. So tell me a little bit, how much do you do with, we haven't touched on this yet, but are you starting to get into any sort of robotics automation or any sort of, at least, the minimum of inside of a manufacturing cell, you have a program or robot that would load or unload, a machine tool, or it would load up a pallet, right, or something. Tell me what you do with robotics automation. Are you really involved with that?
So the involvement for me specifically in the past, you were talking about a gantry machine as a milling machine, but there are actually gantry loaders for turning machines as well. So
Yeah.
you would think as like, a rail on the top of a turning machine, and that rail would come in and drop down, load a part into the chuck, spin around, take a part out of the other chuck, turn 180 degrees and move it over into another chuck, spin around, take a part out, come up, and then take off again. Uh, those type of gantry loaders, as we were talking earlier, those are driven almost exclusively through like macro B programs or even just regular G code programs. In automation right now, the automation for our side of things is on the Renishaw side. So we're able to automate some of the processes that we discussed already. Robotics are really a difficult way to get your manufacturing floor to think outside the box.
I see.
The manufacturing floor, John, thinks of itself as, there's got to be a guy standing in front of the machine, or there's got to be a person standing in front of the machine loading parts or unloading parts or checking parts or something along those lines. What happens if a tool breaks? What happens if, the spindle stops turning? What happens if, right? A robot in the past didn't have that sort of connection. The brain of the robot and the brain of the controller were almost separate. In other words, the PLC on the control side of things will hit an M code. It'll say, wait here because I need to talk over to the robot. And when that robot receives that signal, it says, okay, I'm able to do what I need to do now. The door might open up. It may be able to go in and do what it needs to do. The door closes. The robot then tells the controller, okay, I'm done. I'm finished with what I'm doing. And then the controller says, okay, I can keep doing now what I need to do. I can go and start cutting the part again. The integration between those two brains or those two minds is becoming more and more melded now. The robot knows kind of what the machine is doing, and the machine is telling the robot to do things more than just load or unload parts. Robots are able to do very complex welding right now. They're actually able to go in and probe parts. If you think of like, say, a Faro arm or something along those lines, those are becoming more and more automated or robotic. And we're seeing that sort of grow, but it's one of those things, John, it kind of grows and then it plateaus. And then it sort of takes another little spike and then it plateaus. And then it takes another little spike and it plateaus.
I would think that as we're moving into, this world, this great new world, right, of manufacturing, especially onshoring here back to the United States where we're located, I would think that robotics would play kind of a very important position in the new manufacturing shops that are being created. And the way that they work together, the way you described, is just fascinating because it can really up production and make a huge difference, make us very, very competitive.
Yeah, so robots in the past, John, used to be extremely expensive. It was $100,000 to purchase a single-use robot. And I'm not even talking about it within a cell. I'm talking about just a single-use robot, one robot, one machine. And those were the only two things that were interfacing with each other. Now we're at the point to where, say, a $20,000 or $30,000 investment can be used where one robot is servicing 2 or 3 stations. So it's taking a part out of a turning machine and loading it into a milling machine, taking that part out of the milling machine and moving it over to an inspection station.
I see.
And then going around and taking a part maybe off of a pallet or something off of a loader and loading that new part into the thing.
So this would be almost like a dedicated manufacturing cell for like maybe one particular product.
Right. So that's really where, like we were talking about, that niche sort of comes into play, right? It's a customer that has a particular part that they're just running thousands and thousands and thousands of, and it makes sense for them to put that robot in that cell. But again, we're going back to, what if a tool breaks? Or
Right.
what if a part comes flying out of a vise? Or what if a part comes flying out of a chuck? Or
Yes.
what if when the part gets to the inspection station, it's not good, something's wrong? Now, what you've got to do is you've got to shut the entire cell down. You're no longer just shutting
Oh,
down one machine, you're
right.
shutting down the entire cell. So there are benefits, but those benefits can sometimes be outweighed by some of the difficulties that you'll face in shutting down the entire cell to get back. Because in order for someone to step into that cell, that robot cannot be working. It does not know that there's a person there.
Sure. I totally get that. I think that we're going to see this area of manufacturing begin to just explode over the next 10 years. It's got every indication that it will. So I want to switch gears just a little bit, and I want to come back to and ask you, because I've never done this. I've never been a contract programmer. I've always I've had my own shop and things like that, but worked for very large companies in oil and gas. But I've never been a contract programmer. So I'm always fascinated with watching you do the different stuff that you do. Tell me a little bit about the life of a contract NC programmer. Why would they do it? I mean, why do it? What's it like? What are the rewards? Because we don't talk about that much in manufacturing. What's the life of a contract, NC programmer? So can you give us some insights?
Sure, John. It's very solitudinal. It's me sitting in front of my CAM system for hours and hours and hours, or one of our programmers working alone, uninterrupted, on interfacing just primarily with their PC, right? And there's a specific type of person that's able to do that. Someone that is more of, introverted, someone that's able to sort of think through the entire process, break things up into steps, and start working methodically through the whole process. The benefits are, of course, is you're paid well.
Ah,
Customers don't look for contract programmers when their internal programmers can handle the job just fine. There's no reason to pay a contract programmer when their internal guys and gals are able to handle things. We get the work that everyone else has either failed at or is just not capable of doing for whatever reason. It can be a time constraint. It can be that there's a new machine tool in place. It can be that there's new cutting tools in place, or there's a part that they've never machined before, or even anything similar to it where we've had that experience. We know similar parts, maybe not that specific part, but we've done enough similar parts to be able to go in and be the benefit. But it's very it's a quiet life, John. It's a very quiet life until you actually get in front of the customer, right? So one of the things that you might not think of is, like, how much time do I spend at the customer as opposed to, say, spending it at my office or spending it.
yes. Very interested to know that.
Right. So there's that sort of that curve, right? The curve initially up front is a lot of time with the customer. What's going on? What are the goals? Where do we want to be? And let's start choosing the right tooling, the right fixturing right now. Before I even put any tool path to anything, we need to know, what tombstone are we using? What vise are we using? What chuck jaws are we using? What tooling are we using? How long is that tool? How short is that tool? so that when the simulation is run correctly in the CAM software, right? So NCG CAM is capable of showing the tombstone, is capable of showing the vise, is capable of showing the actual entire machine, all of the machine's features, all moving simultaneously and synchronously.
And I imagine that this helps with any sort of collisions and reachability issues or things like that.
Exactly. Yeah. So that's where the important parts, you might say, like where the rubber meets the road is, as a contract programmer, I am expected, or our team is expected, to have no collisions. When we hand a program off to a customer, that program's got to be right. There cannot be hiccups or mistakes, or we don't have that leeway that, say, an internal programmer might have. Oh, I forgot to do this, or we loaded the wrong tool, or something along those lines. We don't have that. We don't have that flexibility.
Well, that brings up a really interesting thought on my part. For the first article inspection and the first article run, will you typically be there on site?
I
Tell me a
will.
little bit, tell me a little bit about that, and why is that necessary?
It's necessary for someone from GPI to be on site because we don't know exactly where the customer's team is at, right? Did their person actually find the right spot on the vise when they touched off? Did they set the correct work offset? Did they not set the correct work? Did they load tools incorrectly? Are they not loading tools incorrectly? And that is, when you're on site, you get to see that. And, after doing this for 30 some odd years, I can spot things almost immediately, John, just simply by walking up to the bench and looking at how neat the bench is or how not neat the bench is, what kind of tools are being used. Is the machine tool itself being maintained properly? Is it not being maintained properly? Does the operator or the machinist know how to use the probe, not know how to use the probe? Can he calibrate, or can she calibrate the probe? Can she not? And then we start going into the training side of things. And that's one of the things we haven't touched on yet.
Well, let's talk a little bit about that. Talk to me about your training. Is it custom, or for any particular contract program that you write? Is there training for how to run that program and best practices, etc.? Expand on that, on the training just a little bit for us.
So that's really where the value add for our customers really comes into play, right? When we walk into a shop and we've got the experience of having worked in multiple layers and multiple levels and multiple areas of manufacturing, and be able to train internally their people on how to use their own equipment, the machine tools that they purchased, the tooling that they purchased, the fixturing and the work holding how do they get the best out of that? And how do they learn from, say, my failures or my other customers' failures so that they don't repeat those failures? And that's a lot of just sort of intimate one-on-one training with either a machinist or a manager or a supervisor or even the QC department. There's a lot of times where the QC department will come up to us and say, how do I check this part? I don't understand how to check this part. And, we try and explain to them, you check the part the way that we machined the part. First, you find the datums. Once you find the datums, then you can go out and start checking the features.
Oh, very, very good. What I'd like to do is, I'm not sure if we can go ahead and put up the actual website, the actual link to the website for GPI Machine Tool. There we go. So I recommend to all of our audience, if you get a moment, please go out to gpimachinetools.com, and you're going to find a very fascinating solution set that the GPI has put together, and that George is obviously fantastic in using to the success of all his customers. I know, George, that over the years I've certainly enjoyed working with you. It's been such a privilege, and you're just really on the cutting edge. And I don't see how you do what you do with all these difficult parts. I know that I've worked with you on just a few of them, and I'm like pulling my hair out. It was interesting to watch you be able to take that ball and run with it, and do some of the things that you do. I think if we've got a moment, if we've got any questions from the audience, I'd like to take those and see if we can let George answer any questions, if there are any. So there's no questions in the chat. Well, listen, in that case, I want to thank everybody for tuning in today to SolidWorks Manufacturing Live. I especially want to thank you, George. You've been a fantastic guest, and of course, your knowledge is just incredible. And appreciate you and all that you do for our communities in the world of manufacturing. And at this moment, we're just about at the top of the hour. And I think what I'd like to do is thank everybody and go ahead and end the session. And we'll see you again soon, George.
All right, John, take care.